Good afternoon, everyone. So today is April 5th, 2023. Our discussion today for CSE 102 will be related to testing. There's some binary IO slides in there too. We may go over that, but really testing is what I want to spend the majority of our time on today and tomorrow because it is such an important part of making sure that our software is good, is quality, making sure that our software has quality and that it meets the needs of our customers and our users. But first, a couple of things. First, let's start the day off well. William Shakespeare brings us our quote today that a fool thinks himself to be wise, but a wise man knows himself to be a fool. The reason why I bring this quote to you today is not because William Shakespeare was a famous engineer, but because so many people have a wrong belief about why testing is done. We think too often that testing is done to prove that a system works, when in actuality we cannot prove that a system works. We can only find places where it does not. So we'll talk about how we can go about doing that, how we can test our code. Specifically, we talk about JUnit and how to write test cases and how to even talk a little bit about how to create good test cases. Okay, so, but first, there is one thing I wanted to talk about too. You guys got this form, this poll recently. Some of you have already responded to it. Thank you very much. I think I've got about 93 responses. Great. All right. But I think some of you did not quite understand what the second question was about, because many of you answered a no option up here, but then didn't choose one of these. So we need to figure out how to do that, because so this is not a decision to make face-to-face lectures happen, but there have been people who have messaged me asking me about this, and I'm not sure what the rules are or what the instructions are for how we are going to do face-to-face lectures if we do them. But basically, I wanted to get an idea of how many students will attend the face-to-face lectures if they are given. If we give face-to-face lectures, we will not be able to provide online lectures at the same time because I will be in the classroom and we don't have the equipment available to us to be able to also provide video online lessons at the same time. Okay, we don't have the ability to record in the classroom. We don't have cameras. There's no film studio, right, in there. So if we have face-to-face lectures, then what I will need to do is I will need to provide you with a link to a YouTube playlist of some of the video lectures that I provided during the pandemic times, which is fine. You can watch those, but then I need to figure out a way to get you an attendance grade if you do not attend the face-to-face lectures. And that's where this second question came in. If you are unable to attend the in-person lectures, or if you choose not to, attend the face-to-face lectures, not because you're not able to, because you just don't want to, then you will need to watch the video lectures, and we will need to have some way to determine that you did indeed watch those video lectures. And so two options that I have put below is that you could record a short video response to the lecture after you've viewed it, and then send that to me. Send that to me or the teaching assistant in some way, and then we could watch it to verify that you watched that particular topic. Okay. The other possibility is at near the end of the semester, because we have to have grades in before final exams. Near the end of the semester is we have a video chat interview where we ask you questions, okay, about the topics that were covered during the course of the topics that were covered and the lectures during the course of the semester. Okay, so if you are if you are not able to attend the in-person lectures, we may have to go with one of these to determine attendance, your attendance score. In the same way, if you would prefer not to watch the video lectures, you will still need to have one of these. Again, if the face-to-face lectures are given. If they're not given at all, which that may not be my decision to make, there may be others who make that decision for us. Right? But if you are not able to attend, or if you would prefer not to attend, choose one of those options, but then choose which way you would like to deal with your attendance and or quiz scores. Finally, to this, I am not able to attend in-person lectures. Like if you are in a place that you are not able to attend for some reason, like you are, like you're displaced because of the earthquake, you are not able to stay here because you were in the dorms and there's families in the dorms now. I don't know if that's the case. You might be required to provide some documentation for why it is that you are not able to attend. Again, that's one of those things I don't know for sure. Okay, but it is possible that they may require us to get from you documentation for why you are not able to attend. Okay. So, yeah. Okay, so I hope that clears things up, because I think based on the responses that I'm getting, some of you did not understand that what these options meant. Right? So if that's you, then I can remove your response and you can submit a new response so that we can have a better idea of what it is that we are looking at from you going forward. And like I said, again, that may not be my decision to make. This may be someone else higher up than me that makes this decision for us, and we have to go with whatever that is. Okay? All right, so again, if you are able to attend the face-to-face lectures, just click yes and say that's what I prefer. If not, choose one of these two options, and then if you choose one of these, you have to choose one of these. Okay? All right. Yeah, that's it. Let's see, closing that out. Actually, I have a way I could have done this. Okay, anyway, okay. Let's move on into testing. All right. So the way that we can run test cases in Java is through what's called JUnit. Okay. JUnit creates a test class file that has a set of test cases. It runs those test cases on a piece of Java code and generates a test report. Okay. Some simple tests. Oh, you know what? We don't have the asserts. Do we have asserts in here? The asserts in the other. I left the assert slides. I meant to copy those over into this set of slides, so let me pull those up while I'm thinking about it. What are the exceptions? Make sure. Okay, so the basis for the test class, the JUnit test cases in Java, is the assertion. Okay, now the assertions, these slides are part of the exceptions slide deck that we talked about last week. And basically, what an assertion does is it generates, it's a one-line type of, generates an error if a specific condition is encountered. Okay. So we can say assert whatever, right? Or assert with a message, right? where the assertion is a Boolean expression. Now, so if assertions are activated, then when that line happens, when that line is encountered during the run, right, when it's executed, if the assertion Boolean value is false, the assertion error will be thrown. Right? If it's true, then it will continue on. Quick look at an example here. All right, so let's just pull that up as an example. Yeah. So we'll pull that up in my trusty JGrasp here. So now we can compile this. We can run. You know, let me make sure assertions are. Where? I forgot to enable assertions. Okay, so we're going to see what happens when I forgot to enable assertions. So we'll see what happens regardless here. All right, so if we step through this, all right, so I is 0, sum is 0. Okay, we keep going up. I is now 1, sum should be now 1. And so we're going to keep going until I is 10. Okay, now assert I is 10. Problem is I don't have assertions enabled, so nothing's going to happen, right? But now, is sum greater than 10? Yeah. And sum is less than 20? No. So this would be false. So this should generate an assertion, but because I forgot to enable assertions, nothing's going to happen. So this is the nice thing where we can put checks in our code that in the final version might not, the users won't see them. Okay, we can put checks in us for when we're doing debug stuff, like if we don't have access to a debug mode. All right, so let's go ahead and do enable assertions. All right, and let's run it. Okay, so now when we get to the end here, nothing happens there, but when we hit this line, we should get an error, right? All right, so we got the assertion error. So it's a way that we can put some checks in our code along the way that when we actually, excuse me, when we actually create the executable code for users, they won't see this because their assertions won't be enabled, but we can enable them for us. Okay. There was what we used to do back when I was your age, was we would put stuff like this in our code so that if for some reason we would get some error or we would get some logical error, like we're running our code and the output is different than what we expect, you know, we would start throwing in these like got here lines to different parts of our code to see why it wasn't reaching some spot, but it was reaching another, that kind of thing. So then before we would turn in our assignment to our professor, we would have to go back through and do like Control F, you know, find got here. Right. And it has to go find it. Oh, why are you not finding it? Oh, is it? Ah, it's case sensitive. All right, so then we say, oh wait, we got a got here line. Let's delete it. And then, so assertions are one of those ways that we can allow for we can kind of have these test spots along the way that when we disable assertions, so for example here, if we were to compile this and just run it, we get an exception. But then if we say, okay, I want to not enable assertions, and I'm going to run that, then it displays our dot here. Okay. All right. So this could be some type of check condition that if this particular thing is true, or rather if this particular condition is false, I don't want to continue the program. I want it to stop, and I want to generate an error. Then we can do that with a Boolean condition here, and then it just throws an exception, and we don't continue. All right. So let's talk a little bit about then test cases in. Let's see, I'm going to do that. Go back to testing. Okay. Let's go and look at an example of a test class. Okay. So here, notice a couple of things. One, we have the notation that tells us that this next method is a test. Test methods are void methods. This text of this test case will run. And then if there is an exception encountered in this test method, it will basically be treated as a failed test case. Okay. So notice that all test case methods must be named differently. So you can't have an M1 and another M1. You'll get a compiler error because it'll tell you that you can't have two methods with the same name with the same method signature. All right, so remember, overloading a method is where you have overloading a method is where you have the same method name but with a different parameter type, or the same method name with a different return type. All right. But here, this tells me it's the same return type, it's the same parameter type, right? Can't have the same name. Test methods don't take any parameters. If we want to have some common objects, right, some common like a string object or any type of object used for all methods, we can do that through the setup. We can set those things up in the setup method. This is going to be the only one. The before tells the test method, tells the test class, run this method first before all the others. We also have an after for things that we can do for if we need to tear down anything, if we need to take anything down. The test methods, there is no specific order to how they're run. Okay. So it could be run M1 then M2. It could be run M2 then M1. When it goes to run these, it's not going to run them in any specific order. All right. We can run the test. So this is an example array list. We'll talk about that one in just a moment. We may not do the loan class. We'll talk through the array list one here. Okay, so let's do the array list test and show how this works. Now, this particular naming convention for an array, for a test class, is my choice. Okay, that's how I name the array list. Sorry, that's how I name the test case. There's a reason for this, right? Because if you look back at this, notice that these are not the same. This is not the same as this. Right? There's a couple of things that you'll notice if you look here that's different. Right? One is that my test methods are not named the same. This is test insertion and test deletion. I have TC001, TC002, arrayless insert, arrayless insert. This was their original test insertion. All right. Okay, yeah, that's right. I'll get to that in a second. Okay. And then I do have their test deletion. Now there's a reason for this. There's a reason for why I have mine set up here differently from the way they have theirs. A couple of things. One, I like numbering my test cases so that I can know how to find them. So for example, let's say that for your homework assignments, that is the store program, right? You have some classes you have to create, right? You have to create a product class. You have to create a food product class. You have to create a cleaning product class. You have to create a customer class and a club customer class and a store class, right? So what I would do is I would say, like, my test case 0, 0 whatever, 0xx, right? So all the test cases that begin with 0 are going to be like some type of general test maybe. And then I would say any test cases beginning with 1 is my product test cases. My test case 2 is my food product test, right? So this is how I would possibly set up a set of test cases, right? And then that way, whenever I see a test case failure, I immediately know what class it is dealing with, right? Just based on what this value is. Okay? It's a little bit of organization, right? Naming convention. Okay. The other thing that you'll notice is as I've taken their test insertion test and I've made 2 tests out of it. This is because for me my first job in software development was as a tester, right? But for me, I want to have only one assert statement, if possible, in a test, because it shows that we are testing one thing, right? I want to see that we are testing one thing. So a single assert is probably the best way to make sure that we are testing one thing. We are testing, can a single value be added to an empty array list? Okay. Here we are saying, can a value be added to an array list that has values already? So we're testing something specific here. Can a single value be added to an empty array list? Here the thing we're testing is, can a value be added to an array list that already has a value? Okay. All right. Notice that it tests the same things here. So now when we compile this, oh, I need to make it be I think I have to add it to a package. Let's see, I think I have to add it to a new project. Can I get a new project? No, there is a new project. There it is. Okay. Yeah, it has to. I think in JGrasp it has to be added to a project. Now, notice what I want you to notice about this is how the symbols here changed for JGrasp. Okay, So when we change the type here, when this now recognized that this is a test file, okay, this now recognizes that this is a test file, it changes what these symbols look like. Because like if I come back to this other thing here, notice the symbols are different. They're colored differently. That's because this now sees that this is not a normal Java program file. This is a test case file. Okay. So now I can compile it as a test case. Okay, now that should work. Yeah. All right. So now when we run it, right, we get 4 tests passed. We can see, you know, all of these passed. That's good. We like passing tests, right? Okay. But let's see what would have happened. Let's see what happens if we didn't pass a test case. Okay. Compiling is fine. When we go to run it, okay, we got a failure, right? We expected Beijing, but was Beijing, right? So it can show us what it was that was expected, what it was that we got, right? Which can give us information about why this test failed. Now, it could be that something was wrong with the code, right? Like this add to the list, that was the wrong value. We weren't supposed to add Beijing, we were supposed to add Beijing, right? So the code was wrong, right? But a test can also fail if the test is bad, right? If this test case is bad as well. Because we'll get the same failure, slightly different message, right? Well, expected Beijing, but was Beijing, right? But now this represents that our test was bad, right? So a failure of a test, we should not be afraid of a test case failure because it can expose where either the test is bad or the code is got an error in it. Okay. But notice too here, watch. Here, let's say the code was incorrect and the test is correct. Okay. And let's say here the same is true with this one. And let's do the same thing to this one where they put both of these tests into the same one. Okay, so we'll run this once like this without changing it in theirs. We'll only change it in mine. I get 2 test failures. Okay, because I was testing 2 different things and I failed on both of them. But if I do the same thing to them, same thing to theirs. Is that right? Oh, I gotta do that opposite here. If I do the same thing on theirs as I did on mine, and I run it, I only get 1 test failure. But really, both of these are bad, right? Both of these did not work correctly. All right. So, but I only got 1 failure. But yet there were 2 parts of my code that were bad. This is another reason that I say separate these out into 2 test cases. Okay. Now, so let's put that back. Compile it. Run it. Okay. Great. Now we got 4 passes again. All right. So we test for different things to make sure that we know exactly what it is that's failing. Okay. So let's do one or 2 other things and then we'll take a break. So here I have a course class that I created. All right. with a couple of what's it called, an exception, where I made it myself. I made this exception myself. Okay, so this is something that we worked on together the class worked on last year when I taught this course. But I want to show you how you can make a test program for this. So let's say I want to create a test file. Do that. So it already exists. So let me do this. I don't want to lose this because I think there's a lot of good stuff in here. So let's. All right, because I may come back to this. So I want to create a test file. So now when you first create a test file, it's going to take whatever your public class is and create it as that, but with the word test on the end. It'll create a before for you for setup, for anything you want to do in there. And then it will create a test, a default test that always fails. This is so that you can make sure that all your test stuff is set up correctly by compiling and running and getting a quick test failure. Basically, what this test does is this is the first string parameter is what error message should I give if this test fails, and then it's assert equals. So it's saying does this value equal this value, and of course 0 does not equal 1. I hope you guys know that. All right, and so this test will fail. Now, again, this is basically set up so that you can quickly compile it and run it. Make sure that all your test setup stuff is operating well, right? And then you can test this to make sure that this fails before deleting it. So you're going to want to delete this test once you've added your own test cases. You could also do this. You could also do an assert true, and you could put the parameter false here, and it would do the same thing. So we're going to assert that it's true, and we're going to get false because we expected it should have been true, but it was false. All right. Okay, so what we're going to do is we're going to start creating test cases. So for example, in our course class here, right, there's a lot that we could sit here and test with, right? Let's see, let's do a quick one just to make sure, just to say, okay, we're going to test that when we create a course, right? Let's see, with a prerequisite, it's not okay. When we create a course with no prerequisite, that the code that we gave is correct. Okay. So we're going to create a new test case. Just give it a different name. Test case 001 underscore course constructor. Okay, so we're going to test that we can create a course in our class here. Okay, so course C equals new course that takes what as parameters? A code, a title, and an akatese. Okay, so CSE 102. Title. Computer programming. How many akatese is this? I think it's 4, right? Oh, 102. Let's call it 102T. And it has 4 because I think the lab is now separate. So now we're going to say assert equals source code not correct, because that's the message we want to know. We want to make sure that what we expect, which is this, is the same as c.get code. So now when we run this, nope, I forgot the assert. So now when we run this, we should get one passed test case, right? That's what we would expect because we expected 102T to come back and we got 102, we got CSE 102T to come back. Okay. Now what if we, let's see, what if set code, let's say if someone passed us a code that had lowercase letters in it, we want to uppercase it because, you know, this, that doesn't make much sense, all right? Okay, because lowercase CSE doesn't make much sense, right? So we're going to check that this is correct, right? That this is going to correctly set our course code that way. But when we were writing our test cases, what we did was we said, you know what, we're just going to copy this over here to here. Right? We're just going to copy that over there to there. What we're going to get is we're going to get a failed test case, right? Because it expected lowercase CSE, but what it gave back was an uppercase CSE. Which one of these is correct? Well, if the customer wanted uppercase CSE, then the test case is wrong. Right? What are other things we need to test in that constructor? To also check the title, right? All right. And we can also check the to say, right? So if we compile these, nope, I think I may have typed it wrong. Big A and lowercase k, yes. All right. So now when we run this, we get 3 passed test cases. But what if somebody was they were coding this up very fast, right? And when they were making this course class, they said, well, I'm just going to copy this to here. And I'm just going to change this to title and this to title and this to title and this to title. Okay. And they just quickly did that, right? Now, when we run this, we should get, not compile. We should get a failed test case, right? And this also shows you something I was saying earlier, that the test runner does not run a test cases in a specific order. Notice it did 1 and then 3 and then 2. Right, that's the way the output comes through. And this is not because the TC002 failed and therefore it came last. What you'll see when you start running these is any failed test cases will be all mixed up in there. Okay. So it capitalized all my letters, right? Which is not what I intended to have happen. So my test case is correct in this example, possibly, probably. My code was what was incorrect, right? Because I just quickly I just copied this to here and then just made some changes to make it work, right? Okay. All right. So to make this correct, if you will, we're going to take that 2 uppercase off, build it, and then now when we run it, we should get. Now notice that just for that one constructor, I was able to generate 3 test cases. Then I can also create 3 more test cases for setting, right? For set title. And so now I create my course. And I make sure that my code was changed correctly. I'm going to do the same thing with title. And I make sure that my title is set correctly. And the same thing with Akatese, right? Actually, these numbers are wrong. It doesn't matter because the method names are different. Oh, that's one thing. That's another thing about numbering your test cases like this is by making the method names different, you avoid compiler errors. So then you run it and we get 6. So just from the constructors and the set methods, I was able to get 6 test cases. Now, the reason why I showed you this was there's a temptation that you might say, oh, you know what? That was 6 passed test cases. That's a lot for just that simple thing of a constructor and the set methods. So anytime I run a test case that doesn't generate an error, I get a pass test case. Well, what if I did this? Compile it, works fine. I run it. I got 8 pass test cases, right? Because 4 of my tests do nothing, right? There is no code in them. There's no error that was encountered. So therefore it passed, right? Don't do that, all right? You'll get a lot of pass test cases and you can try to convince your customer or your boss that you did a bunch of stuff because look at all the test cases that got passed, right? But this is not helping you find errors in the code, right? Okay. Oh, it's 4:20. So what we'll do is we'll take a break and then we will come back and we'll continue on. Okay. Oh. The product IDs, if you look, I don't know if it matters if it's a primitive long or a the wrapper class for long, but if you notice in the example, I pass a primitive long value. So when I did it, it was a primitive type. The add to cart method should take the product that the customer is requesting and put it into whatever collection you decide to use in your customer class to represent the items that are in their cart. Okay. I intentionally did not tell you what type of collection to use because that's up to you. You can use an array, you can use an array list, you can use other collections if you know how to use them, but expect that if you do, we will ask you why. What made that collection better than any other collection? Okay. So basically the add to cart method, we look at it. Good question. Let's see. If we look at assignment 2 here. So customer here, add to cart is going to take a product and how many of that product they want. Right? And it's going to take that product and put it into the customer's cart for the purposes of purchasing it. Okay. Let's see. So you will need to purchase the method from the product class to make sure that there is enough of that product remaining for the customer to have it, right? And then we'll add it to the receipt string and the total due if the purchase is successful. So if we look down here at the examples, this one has a bunch of exceptions, but basically here I add product P, which was the computer. So I added 2 computers to my cart. Here, the get product, I use instead of adding directly through the FP, right? I can add by using the store get product method to get the Snickers product and add -2. Oh, exception, but it's caught inside of the add to cart method, right? And then it continues on. So now I can add 1 Snickers and then find out how much is the total due. 2 computers, 1 Snickers, the total due is 2002. All right. And then the reason why there's not enough payment, after paying 2000, I get an exception because 2000 is less than 2002. I hope we all know that. And then we pay 2020 instead after I comment out that exception. All right, so then I get 18 back. That's telling me how much I get back. Okay. Another couple of things you notice that in the way I made this, Snickers twice is put into my cart. Once I put 2 Snickers in there, once I put 1 Snickers in there. These are old prices, aren't they? Once I put 2 and once I put 1, it resulted in 2 separate line items on the receipt. If you want to do it as 1 line item on the receipt, Snickers 2.0 times 3, that's fine. You can do that. Okay. There's no that you can do it that way. That's fine. Okay, but notice that for me, mine, every time I purchased it, every time I added it to cart, it resulted in a different line item. Okay. Let's see. Hand construction. Right, yeah, because if you give a bad value to a constructor, you should throw an exception in the constructor as well. Absolutely. So about the hash-based collections, you can use the hash. I guess in this case you would use a hash set because we're not finding by index. Yeah. Yeah, you could, if you know how to use them, yeah, that should be fine. Again, mostly we're testing the methods that we defined. And as long as they give the correct output or give the correct return value that we're expecting, then everything should be fine. Okay. We should not be testing what the interiors of your code. We're doing what's called black box testing. We'll talk that. We'll do that. We'll talk more about black box and white box testing next. Okay. All right. Let's take our break and then we'll continue after.